Hello, everyone, and thank you for joining us today. We demonstrate Subsurface AI's new Petrel data connector functionality. For today's session, from the Subsurface AI team, we have joining us Renjin Wen, President and Founder of Subsurface AI, Cindy Luo, our Product Manager, who will be driving this demonstration, Ronfeng Zhang, our Technical Support Manager, who will be supporting Q&A, and I'm Art Valdez, Senior Technical Advisor, and I'll be serving as your speaker. We've reserved an hour for this webinar, although we don't expect that we'll need all of that time. The demonstration shouldn't last longer than about 25 minutes, after which we will hold a live Q&A discussion, so the audio for our attendees will be muted until then. However, if you would like to ask any questions during the presentation, feel free to type directly into the chat, and our team will address any questions for you. To begin, we do have a few important notes to highlight regarding our new Petrel connector functionality. It is available now, concurrent with Subsurface AI's latest 25.2 release. The data connector supports Petrel versions 2023 and 2024, so the plan going forward is to ensure that our data connector always supports the two most recent versions of Petrel. It includes bidirectional transfer of data from Petrel to Subsurface AI and then back to Petrel, which we'll demonstrate. The connector is separately licensed, so there's no package dependence or need to have another licensed module in order to acquire it. And we do support multiple data types at this time. The Petrel GeoModel will be planned for support in the next Subsurface AI release as we further develop. So we'll demonstrate what we currently have today for you. With those notes, now we'll jump directly into our software for a live demonstration. So what Cindy has open right now is an existing Petrel project with lots of data types, 3D seismic volume, some well data, some logs, and a few others as well. What we're going to do first is launch Subsurface AI and create a new project and talk about the interface, and then perform a data transfer from Petrel to her new project. So we'll create something new, we'll take the default values, and we can see here that we have an empty project with nothing in the data tree. So we've introduced a new icon in the icon row to launch the Petrel connector, which you can see here. And clicking on that icon will open the interface. And we'll talk about this layout here for a moment. So at the top, we have the controls for the data directionality, whether it's from Petrel to Subsurface AI or from Subsurface AI back to Petrel. We want to make sure we have an active Petrel project open. So that project is going to be selected from the pull-down menu on the left. We have a search functionality, which is very handy. This allows users to type in a text string to search for individual elements that might be included in all of the data that are scanned from the Petrel project in order to make a transfer across these tabs. And of course, the data types are separated. So we have tabs for seismic data, wells, horizons, surfaces, and faults. There's an additional toggle option for seismic to include 3D volumes with the same geometry in a single 3D survey. And finally, we have a toggle to turn on or off the data types if you want to select all or deselect all. That can be applied either tab by tab, or it can be applied across all of the tabs together to limit your selections. So let's look at the seismic tab to start. In this example, we're just working with a simple 3D volume, but we do support both 2D and 3D seismic data sets. We can import multiple surveys, multiple vintages if you're working with 2D seismic, and a very rigorous hierarchy of how that seismic data is stored, not just in Subsurface AI's data tree, but also represented in the connector. In the Wells tab, we'll see that we have an interface that's pretty familiar to those of you who might have used the Sizeware connector in Subsurface AI. So on the left, we have our Wells tab where individual wells can be selected by checking on or checking off. And those can be expanded to include, by choice, any accompanying well logs that you might have in your Petrel project as well. I do want to note that we do support control click and shift click for multi-selection functionality. So if you do have a lot of data elements to activate and check or uncheck, you can do that within the connector as well. The panels on the right, first we have a toggle for time depth curves. So that will allow the user to include those in the data transfer. And then we have additional panels for log curves and well tops. The log curves panel is going to serve to import well log groups. So selecting a well log group in this case will allow the user to select all of the logs for all wells of a given type, sonic, gamma ray, density, and so forth. However, you do want to ensure that for those log groups to be imported, the wells themselves need to be selected in the left panel. So any well that's selected in the left panel will be one in which that well log group will be included for. And then finally on the right, we have our panel for well tops. And again, these can be checked on and selected individually or in bulk. So very flexible in allowing the users to see all of their data within these connector panels and select or deselect any option that they want to bring in. So let's move over to the Horizons tab, where you can see we have a folder for Horizons. So one important note about Horizons and surfaces, these are two different data types in Petrel. In subsurfaceAI, in the data tree, as you can see behind this window, we have a single tab to store horizon data. So in the case of taking horizons and surfaces from Petrel, both of those data types will be stored in the Horizons tab, but they will be included under their own respective folders for horizons and surfaces. So again, these can be selected individually or in bulk from your existing project. And then finally, in this example, we have some faults. So that's going to include our fault interpretations, imported as fault sticks. Cindy will select those as well. And now we have all of those different elements across all tabs selected for import. So she will activate the data transfer and we'll watch that occur in real time. This is very performant. We are working with just a small data set here as an example, but even for large data sets, hundreds or thousands of wells, we can expect this transfer to be very efficient. And now you can see that we have all of that data brought across the link, and Cindy's going to open up some viewers to show you how that would appear. So we've mirrored to the best of our ability everything that exists in the Petrel project that we can now visualize and work with in subsurfaceAI. And Cindy's brought up the seismic volume, some well data. This is a good point to discuss how we handle coordinate reference systems. So there is no active transformation being performed by subsurfaceAI when we're working with these surveys. So it's best to create a subsurfaceAI project with a coordinate reference system that matches your existing Petrel project for the data transfer. Or you can create a subsurfaceAI project without specifying any coordinate reference system. And when the data is transferred over, then subsurfaceAI simply mirrors the projection of the existing Petrel project. Now, in cases when you have a seismic volume like this that might have a different original CRS than that specified for the Petrel project, that information is recorded as well. So you can see the CRS tab in the properties menu allows us to look at that. And also we have an original CRS tab to show us what the projection was if that was different from Petrel. So there's no need for any vetting of geodetics. For those of you who have larger teams, we're simply taking the Petrel CRS for that project and mirroring that in subsurfaceAI. Okay, so now that we have the data brought across, we'll do a very simple example here where Cindy is going to use one of our AI tools to predict a new facies log from the existing well data. We'll do this just to generate a new object, a new data element, and then we can show that transfer back to Petrel. So she's going to generate an unsupervised log facies classification. This is one of our many tools that we can utilize to predict and generate log data from an existing set of logs for data sets that we don't currently have. So she'll select her sonic, her gamma ray. Any of these can be chosen, specified for a number of facies, and clicking OK will output that new classification. So we now have a new log under our well log data tree, and we can turn that on to view it in the 3D viewer. Very quick and easy to do, and we'll show some other examples where we would take this a bit further in order to build out your project for AI interpretation before transferring that data back to Petrel. But for this quick example, we'll go ahead and take this new facies log and we'll take that back to our existing Petrel project. So this time we'll reopen the connector and select the data direction back to Petrel. And in the Wells tab, as we expand these elements, you'll notice that a lot of those entries are gray, and that's because those are pre-existing elements in the Petrel project. The new facies log that Cindy's generated is selectable. It's active because it's different. So we've added that on. She'll check that box and then click OK, and we'll watch that go back to Petrel. Every time data are transferred back to Petrel from subsurfaceAI, the Petrel project is automatically saved. And then we can go back to the Petrel data tree and render that newly transferred facies log in our 3D viewer. We've got multiple data types that we can move back and forth, and we'll start looking at some greater examples, but we just wanted to give the attendees a quick run through of data in, generate new data, and then push it back out. Now, the way that we would take this further, and what many of our clients are doing, is part of our integration AI package, where we can take log data and or seismic attributes and use those with our AI tools to predict or classify new logs and properties that we can generate 3D representations of. So in this well log correlation window, we can see that we've got gaps in an existing density log, and the newly added track is showing us how we fill that gap using our prediction to predict that continuous property. And again, you previously saw how we ran an unsupervised classification in order to predict and generate a discrete property such as facies. So with these new logs generated, we can then generate 3D representations of these property predictions. And this example is showing us a base map and a section view where we can overlay along the all wells line examples of a 3D volume of predicted gamma ray. You can see how that looks against our gamma ray logs. That would be a continuous property example. And also in the base map, we can overlay those results, and we can also switch off to a discrete example for the facies. So we can show the 3 facies representation as well in the base map to generate that. So these are all additional outputs that are very useful for the interpreter, very quickly generated through our AI tools and workflows in subsurfaceAI. And now we can push these new data elements back to Petrel in their additional formats. So Cindy will reopen the connector, and this time she'll go and selectively check all of the new outputs, including the gamma ray predicted volumes from our neural networks. From our wells tab, she can select any predicted wells, density in this example that we've shown. And then we can also look at some maps, including the classification map that we showed previously. And again, all of these can be selected very quickly and transferred together in one go. And then back in Petrel, we can turn these elements on to see how they are mirrored as we generated them in subsurfaceAI. So again, this data transfer is really geared toward efficiency, really simplifying the time and effort it takes for data transfer between the two platforms. If you're an existing Petrel user and you would like to augment your workflows with the powerful AI prediction tools in subsurfaceAI, this is really going to be a boost to your productivity because it's very simple and quick in and out, along with the powerful and expeditious workflows that we have in subsurfaceAI to generate these new elements. Okay, so now we're going to switch gears a bit and talk about some additional types of outputs we might generate in subsurfaceAI using data that we've transferred from Petrel. Namely, these are going to be outputs from our Interp AI module that we're utilizing to identify and train models to predict different geologic features from seismic data. So we've got a few examples here. We'll start with faults. Many of our clients who are using InterpAI start with faults, and this is where we'll look at seismic data, again, either 2D or 3D, perform our own interpretations that we call labels on that seismic to identify these geologic features, and then train a model to predict in the style that we would interpret ourselves. Ultimately, the output of this would be a 3D volume of fault probability, and we do have the tools to co-render that with seismic volumes and even extract our fault sticks, our fault points from that volume, which you see in the 3D visualizer on the right. Again, a very robust and expedient workflow to get a lot of data out quickly using the power of AI. And these additional data types, the fault probability volume and the fault extractions, can be pushed back to Petrel just as easily. And we'll look at a second example here for horizons. So another workflow in our InterpAI module allows us to take raw horizons with maybe poorly interpreted, some gaps and skips. It could be in very raw state. And our AI tools allow us to treat those horizons as horizon labels to train models to predict what we call a stratigraphic sequence. So we can demonstrate what that looks like on a seismic section on the left, and our AI models will predict the intervals between those horizons, but do it with much more continuity than you might find in a standard interpolation package, especially in areas where your data quality is very poor, you have low signal to noise ratio and lots of attenuation. It's a great way to get a very continuous reflector representation with minimal data as input. And when we've generated the stratigraphic sequence and QC that on a section, we can produce a full 3D representation of that. So it's a stratigraphic sequence volume. You can see that in the 3D viewer. And from this sequence volume, the final step is to extract the interfaces, which then represent our interpreted horizons over that larger area. So that is the workflow that we employ to very quickly generate horizons over regional, basin-wide plays with minimal data in a very, very short time. That's much more accurate to the seismic data, the original data, than many auto trackers might be. And then these surfaces and the volume itself can be transferred back to Petrel as well. Our final example here, we wanted to highlight the prediction of some channel features, so some complex braided channels. This is becoming a very popular workflow among our clients, where we're utilizing spectral decomposition volumes generated in subsurfaceAI and color blending those volumes together in order to highlight these channel features. And we like to do this on what we call a stratagrid. So a stratagrid is an interval of interest that we create in subsurfaceAI from one or more horizons by slicing up the interval by any number of straddle slices and then representing that in a section view and also in the base map to slice through that interval by that event. And this is very helpful to render these types of dipping features along a continuous slice. Of course, we can create our own labels as interpretations on these straddle slices and then train the model to predict these features throughout that interval, which is what we've done here. And again, the lower right window will show you what a 3D representation looks like of that interval and also of the captured channel features that was done entirely through minimal training on 2 straddle slices in this example, but then allowing our model to predict those channel features everywhere within that interval. In subsurfaceAI, we can easily convert that back to a volume, and then that probability volume of channels can be transferred back to Petrel for further analysis. So again, just additional workflows are very popular with our current clients for InterpAI, saves the users a lot of time, and it's a great way to generate a lot of these interpretations with the help of our powerful tools. So finally, to wrap this up, we can reopen the Petrel connector. And this time, I believe Cindy is going to create a new project. So we'll start with nothing in Petrel. And we'll launch the connector and select the outputs from our InterpAI module. And again, that will include our fault interpretations, our fault probability volumes, stratigraphic sequence volumes, channel facies volumes as well. And any or all of these can be selected together or individually pushing back anything that we want to look at. Keeping in mind, again, that once you reopen the connector to perform an additional transfer, any pre-existing elements that were transferred before or exist in the Petrel project will, of course, be grayed out. And you can see here, relatively quickly exporting the seismic volumes to ZGY format, and that'll be followed up with the individual elements for the horizons and for the fault. So even with large data sets, thousands of wells, maybe hundreds of gigabytes of seismic, these data transfers are very expedient. We're usually talking about seconds to minutes. It's not going to take you hours to perform. So it is very, very efficient. And finally, we'll reopen our visualizers in Petrel to show everyone what these results look like. So you can see our fault interpretations, inline, crossline, Z-slice representations of our channel volumes. You can play with your color bars to any extent you'd like, but all of the data is included. And there you can see our stratigraphic sequence volume from which we extracted our own horizons in subsurfaceAI. The connector is very, very stable. Multiple data types supported currently, and we plan to flesh that out going forward. Again, planning to support always the two most recent versions of Petrel. This is currently out now. It's available for both Petrel 2023 and 2024 support. All right, so that will wrap up the live portion of the demonstration. For anyone who now has questions or comments, feel free to raise your hand in the chat, and our team will do our best to help address those for you. Thank you.